I'm Rob Marsland. I'm here at ECOC 2016 in Dusseldorf, and I'm showing our optical modulation analyzer, which is used for looking at data signals that are sent over long-haul networks using coherent technology. In particular, what's exciting these days is moving to higher order QAM formats and also to higher baud rates. So this system we're showing here is suitable for 64 gigabaud and actually even up to 80 gigabaud signals work with this. What we have is our 45 gigahertz coherent receiver, and this coherent receiver is connected to two of our oscilloscopes of the SX series. These have 70 gigahertz of bandwidth and 200 gigasamples per second per channel. So with this combination, we can do a single polarization with 45 gigahertz of bandwidth limited by the coherent receiver, or with additional ATI scopes of the SX series, we can achieve dual pole analysis to 45 gigahertz. What we're showing in particular today, though, is a new feature of our software. In this software, it enables you to communicate with more than one optical modulation analyzer at a time. And that's important for whenever you're doing multi-channel measurements, and it's important to have time synchronous information gathered on both or multiple channels. So here we were showing two channels where we had 16 QAM on both, but at completely different wavelengths. And then these were detected by two separate OMAs. So in the software up on the display here, you can see on the left-hand side we have eye diagrams from the two OMAs. The one on the left is wavelength 1, the one on the right is wavelength 2, and then on the right side of the screen there are the constellation diagrams from the two wavelengths. And then just to emphasize that all this data is collected simultaneously from the separate wavelengths, we're plotting the real part in the upper right-hand corner from OMA 1 and the real part of the signal from OMA 2. And you can see the two waveforms are pretty much identical, even though they were collected by two completely different OMAs. And this can be extended up to 8 OMAs pretty straightforwardly. So with this method, if you have more than one OMA in your lab that you're trying to manage, or if you're trying to collect simultaneous data for multi-channel or, for example, spatial division multiplexing type experiments, this software will facilitate that work. Thank you.